Welcome to my channel Crafting Mad. Let me show you something different yet similar to one of our problems. When a string on this guitar is picked, it is oscillating in its natural frequency and creates some sound. Pretty much any mineral object has a resonance frequency it responds to. What is a good thing when it comes to music is a bad thing when it comes to structural calculation. Because even when mineral things are composed to something, they have such resonance frequencies. Maybe you have heard of collapsing bridges under the feet of soldiers. Yes, this really happened and is the reason why soldiers usually break up their rhythmic march when crossing a bridge. Well, our beloved 3D printers will not collapse on resonance frequencies. Usually, soldiers won't run across it either. But the moving axes, which are speeding up fast and slowing down, changing direction in the twinkle of an eye, also make the printer shake and oscillate. And some of those frequencies make it shake so badly that you can see this in your print. Those effects are called ghosting and ringing, making the vertical print surfaces, I refer to walls, less even, less perfect. Input shaping is a software function to measure the frequencies, which create most feedback, which oscillate the most, and once measured, there are filters to suppress those frequencies, which in turn makes your print a bit smoother. Now let's talk about the device I decided for. I wanted a Fysetc ADXL345 because there was an explicit manual for that one on GitHub. Another reason was that I did not want to fiddle around with additional wiring, which is needed for the other variants. This one has a USB-C connector, so with a USB-C to a USB-A cable you could directly plug it to the speeder pad. My only concern was that such USB cables have more mass. For a measurement, aiming for movements, oscillation frequencies, speed and so on, I assume less mass would be better. You can see my device is already screwed on top of a 3D printed part. You need two M3 bolts and nuts for this. I recommend a length of at least 16 mm. More does not hurt either. The 3D part you can see is also done by Github. It is a custom design for the FLSUN V400. You can find it at printables.com. I will add a link in the description below. Prices for hardware went up now for a while, and the times you could buy one of these for less than 10 bucks are gone. When I bought mine, I even paid 25 bucks and it was not labeled to be Fysetc but BCC AMD. But as you can see, it came in a box labeled Fysetc, so I guess there is some branding, rebranding stuff going on. Well, as always, there is some software to be installed. I am again using MobaXterm to do that. If you missed my Klipper install video and want to know more about this tool, just check out the video in the info box. I like to have my notes in a text editor, as you also may know from my previous videos, so I just copy this stuff accordingly. First thing to do is to run an update on the Ubuntu. If the system was recently installed or updated, it won't take much time. After that, you install Python 3 matplotlib for the beautiful graphs you have seen at the end of my intro. The really time-consuming part comes up next. You have to install numpy. You don't know what numpy is? Welcome to the club. I didn't know either, and also the Github Manual won't waste time to explain. Numpy is a package of libraries necessary to execute Python code, which is in turn necessary to control the ADXL345 hardware and also analyze the measurements. And as you can see here, you can grab a coffee meanwhile. It will take about 15 minutes for the full install. As always, still I recorded the procedure for you, so just in case you have issues, you can see how the output should look like. And be reminded, I am using chapters, so if this is too boring for you, just jump to the next chapter. Let's create some firmware again. We will see Pysetonifill for a second time here, but let's go. After changing to the Klipper directory, run the make menu config again. And this will start in the window we already know. Now we need to disable the first option. And we need to select the Raspberry Pi RP2040. And the rest is okay. Bootloader, we do not have any offset, and the COM interface is USB. So basically you just need to quit. You hit Q for that, and then you type Y, so you save it. And to compile the firmware, you send the make clean. And after that make, which will take a little bit. And if that is done, then the firmware is created. And then Pysetonifill will show up. In the Github manual, you should create a mounting point with the ADXL345 and then copy the recently created firmware to that. By doing so, you would have flashed your ADXL345 with the according firmware. And just as I had issues to flash the printer in my last video, I have issues again with flashing the firmware. Hello Phil, and thanks a lot. I have to admit that I got the instruction wrong with my first attempt. It says you have to hold down the boot cell button while you connect with the speeder pad. A little bit further down in the manual it says that it should be disconnected and reconnected without holding the boot cell button this time. I guessed it should be pressed the whole time, which definitely is not correct. It just shall be pressed when connecting the first time. After it's plugged in, you can release it. But even when I did this correctly, anytime I wanted to create the mounting point, it told me that the special device doesn't exist. I tried a few other ways to create the mounting point. I always received the same error. So I guessed, if it is a simple copy action, I just will do this on my Windows PC. So back to Mobile Xterm, checking for the Klipper directory, and inside the Klipper directory there is the out folder, where you can find the klipper.uf2 file, which I finally downloaded to my desktop. Here it is. Then I plugged in the ADXL345 to my PC while pressing the boot cell button, just as mentioned in the Github manual. A new folder pops up like a charm where you can easily copy the firmware to. That's it, done. No mounting point necessary to do that. According to the manual, it should be easy to retrieve the USB serial of the ADXL345. It should show up with this command, but in my case it didn't. To finally fix this and retrieve the USB serial, I was just disconnecting and reconnecting several times, also using different USB ports on the speeder pad. In between, always resending the command again and checking. And finally, I also did a restart of the system. And at some point of time, finally, the USB serial showed up accordingly. When successful, there are two IDs retrieved. The ID mentioning RP2040 is the one which is needed. Copy the ID somehow, so you can use it when you need to modify the ADXL345 _Fysetc.config file accordingly. It needs the serial specified. It also needs a save and restart cycle. Finally, the printer CFG file needs to be modified as well. You need to include the previously modified AXL345 _Fysetc.config file by removing the commenting hashtag. By the way, when done with the measurement, this line should be again commented. Another save and restart cycle and you should be basically good to go. It is time to send the first command to the ADXL345 device by checking with the accelerometer query, which you send by console. When everything is fine, you will retrieve some values with it. There is one more issue before the measurement can be done. The 3D part by GU uses one of the fan mounting points to attach the ADXL to. Unfortunately, there is not enough space for the ADXL to fit in. There is only about 32 mm of clearance. The original ADXL345 by Fysetc uses approximately 53 mm of space. As the outer edges of the circuit board are not used for electronics, I did cut them down with a Dremel tool, but any kind of multi-tool or handsaw fine enough will do the job just as well. At the end, the ADXL sits on the 3D part quite comfortable at about 28 mm. When mounting, I decided to not go for a longer screw like proposed in the Github Manual and mount it on top of the original black fan shroud. I removed the fan shroud and used the original screw as it is meant as a temporary mount anyways. Just because I was interested, I put the two parts on a scale. The black shroud comes in at 10.4 grams, the ADXL with the 3D part and the screws is about 6.8 grams. When adding the wiring to that, it should be close to equal. To confirm the ADXL sensor is working as intended, we do another measurement of the entire machine when idle. When retrieving values in a range of a couple of dozens, the unit should be fine. If you see much higher values, something may not be right. These values seem plausible. Before we go ahead in the manual, it states that you should be ready to switch off your machine in case it is shaking or oscillating too much. I recommend you stick to this advice, even if my testing did not show anything of concern. The test movement of the effector is tiny. The camera can barely pick this up. The measurement for one axis is done in a bit more than 2 minutes, and the second axis is exactly the same as the first one. Keep in mind, we are not testing real axes like our X, Y and Z tower. A Delta printer is always moving all of the axes at once to perform a movement. So on deltas, you only have a virtual x and a virtual y-axis. But this does not matter at all, because the measurement should find out on vibration and oscillation of the whole printer. It was not objective to measure only one physical axis. So just to make sure, if I command the printer to move in x direction, the effector will do a clean move in x direction, while all three axes need to perform a movement to make this happen. This is why I mentioned the virtual axis a few times. It is important to understand. The ADXL will do the precise measurement, but the results of that measurement will be calculated at the speeder pad, which was the reason to install the Python stuff in an earlier step. Here the calculation for the x-axis is done. The calculation will yield an output to the console and a rendered graph for each axis. Each axis needs to be done separately, and so the same procedure is repeated for the y-axis. The output will be done for 5 different filters, which require different setup. The filters have different smoothing power. Aggressive filters can also spoil details or sharp edges. The output also will indicate a recommendation, which filter to use at which settings. Checking the output here first lets me know where the graph was stored. In the final line of each axis computation, the recommendation can be found. In my case, the recommended shaper is MCV, which is the least aggressive filter. It also tells me that the filter shall be set to 46.2 Hz. When checking the MCV filter line, I can find the third parameter needed, the suggested maximum acceleration. The same information, of course, can be found in the second output for the y-axis. The recommendation for my setup and the y-axis is also to use MCV as a shaper, but at a frequency of 48 Hz and a maximum acceleration of 6800. I am not looking for an 8-minute benchy, so in order to get even smoother results, I will turn down the acceleration more than recommended. In my case, it was 6300 and 6800. I think 5000 is more than enough for me. The graphs have been computed at the speeder pad. They also have been stored there. So we just go to the MobiXterm session we used before and check for the proper folder. The graphs are stored at the temp folder in the root directory. So you need to move up 2 folders. Then navigate to the temp folder and there they are. You can download them from here to your desktop. Let's take a closer look at the X-graph, but let's start top right, where you can find the calculation again, pretty much same as you already have seen it in the console output. In the bottom line there is the recommended shaper, which is MCV in my case. It has orange color code. Above the recommendation line, the colored graph symbols will be shown next to the filter name with its according recommended settings. In the top left corner, the line colors are shown next to the vibration direction they belong to. Yes, this test was done for X direction, but vibrations can happen in all directions, even if there was no movement in Y or Z. Therefore, all directions have a graph. Similar to the soldiers running over the bridge, the movement in X direction causes vibrations and oscillations mostly in X direction, but also in Y and even a little bit in Z. The whole structure is shaking and moving. Our eyes are just too slow to see that. Those full line graphs show the intensity of the detected oscillation for a particular frequency in a particular direction. So what you can see in the X test is that the vibrations in X direction reach a maximum in intensity around 44 to 48 Hz. And we can see that the movement in X direction also creates some vibrations in Y direction, also if the intensity is much less significant. The recommended filter MCV, on the other hand, also suppresses most around 40 to 50 Hz when it is set up to the proposed 46.2 Hz. The graph for the Y-axis looks very similar, just the frequency differs a bit. This is also not strange for a Delta printer at all, as the printer is very symmetrically built. On a bad slinger, the Y-axis is completely different in mass and movement dynamics compared to the X-axis. For those printers, it is very likely that the two graphs have much less in common. But for a Delta printer, the physical axes are all the same. Any direction, there is no real difference. Now that we have seen the results, there is one more thing to do. The results have to be applied. I opened the printer config file in my mainsail and had it for the printer settings, where I changed the value for the max acceleration to 5000. In this screenshot it is still 3000, which I did for testing. Also I changed the max axle to diesel to 5000. Again, it was 2500 only for a test. The recommended acceleration was 6400 and 6800 respectively. If you want to max it out, at least go for the lower value to stay within the recommended values. Then check for the input shaper settings and change those to the recommended settings. I changed the frequencies and the filter type accordingly. This cube was an early attempt on my former Snapmaker 2.0 and shows typical ghosting effects. I would have loved to show you crappy prints from the V400 without input shaper and then show you dramatically improved prints with input shaper active. But the truth is that my print quality on the FLSUN V400 was not bad right out of the box, even with FLSUN's version of Klipper. And it further improved by installing original Github Klipper. There is a test print linked in the Github Manual for the input shaper, which I did test as well for the V400. I printed this a few times. Compare this print to this one. Definitely one can say that the two pictures do not show the same part, but to see that here is a ghosting in the imprint of the Y and that there is a slight bulging going on and there is another ghosting echo immediately after the Y, compared to the version which does not have that effects because input shaper was improving the print, is maybe a bit hard to tell. Still, I can confirm that the print with input shaper is smoother and also does not show any ghosting at all, while the print without input shaper has some issues. Even if they are barely visible, the print still looks smoother with input shaper enabled. So, after all, does the effort pay off? Well, it depends. The print quality out of box is already really good. For a V400 with average requirements to speed and print smoothness, you do not have to go down that road. At least from my experience, I can tell that the print quality on the V400 is really good. Print accuracy is a different book, of course, but input shaper also does not affect accuracy. Also, decreasing speed will increase quality. In case you run into ringing or ghosting issues, and you can reduce printing speed, maybe this is also an option for you to improve the print quality by sacrificing speed. I had to switch off input shaping and speed up the printer on my speeder pad in the fine-tuning tab up to 300% in order to create the bad sample which shows some ghosting. I assume when running at more common speeds, like up to 150 mm per second, ghosting should not be an issue at all. In fact, I would be interested in your opinion. If you have encountered significant ghosting in a particular model, please leave a comment with the name of that model and maybe the basic setup you were using. So if all I said up to now does not apply to you, maybe you belong to one of these users. You already run original Github Klipper. In that case, the additional effort is really low, maybe 2 hours, and the improvement is definitely noticeable. At Aliexpress, maybe also you can get an ADXL with USB-C for less than 10 bucks. I would encourage you to give it a go in that case. Also, this could be a con topic if inverted. If you do not have Github Klipper already installed, maybe you should not do this if this is the only reason. If you want to go really fast, then I would strongly recommend to do proper input shaping, maybe even testing with different shapers than the recommended one. And if you are looking for a smooth as it can get print, also go with input shaping. And as said earlier, don't speed too much. My first important note is that there is a documentation to manually determine the resonance frequencies. This is maybe a less precise and sophisticated method, but it also can do the trick. You don't need to bother about the software and hardware, just you and your caliper and your calculator. You just follow the manual and maybe this will also be sufficient for you. I like tech a lot and for me it is always interesting to try something new. But maybe this is not your cup of tea, then maybe this is an option. But as far as I know, input shaping is not possible on the FLSUN version of Klipper. Github Klipper needs to be installed also for the manual approach. My second note is, if you have Github Klipper installed, just try my values and see if this already improves your print. And the last note, I mentioned it already in the video, but do not forget to comment the ADXL345 include statement in the printer config. It was a recommendation in the Github Manual. If you do not do this regularly and have the ADXL345 mounted permanently, there is also no reason to keep it active. You already run original Github Klipper. Gott, ist das eine Katastrophe. You already run original Github Klipper. you already